back. In this video we will be learning a beautiful chapter which is binomial theorem. Okay, we call it as BT in J means and J advanced terms. So before starting into this chapter, people may get confused that is this enough for J means and J advanced. It's my guarantee that all the concepts from J means and J advanced is covered in this video. Fine. The question is your responsibility. The more and more questions you practice, more and more marks you will get. Fine. So there shouldn't be a doubt where this is enough for J means and J advanced. This video is purely made for J means and J advanced only. Fine. So yeah, please be clear about that. Okay, let's start with binomial theorem. In binomial theorem, you will see something called factorial. Fine. What is a factorial? For example, if we take 5 factorial, we denote it by like this. Fine. So what is a 5 factorial? It's nothing but we start from 1 and multiply the consecutive terms till this number comes. This is basically called factorial. Fine. So similarly, 1 factorial is 1, and note that 0 factorial is not 0, it is 1. Fine. So this is an important exception in factorial case. And some of the properties of factorial, like n factorial by n will get n minus 1 factorial. What I mean is, so 3 multiplied by 4, right? So this is 4 factorial, and I divide it by 4. So what I'll get? 3 factorial, right? So that's what I have said in this. Fine. So moving further, so that you will be learning something called NCR in this chapter. So NCR is nothing but n factorial by r factorial n minus r factorial. Fine. So for example, 5c1. So how will you denote 5 factorial by 1 factorial 4 factorial? This is how you will denote this. Fine. Okay. So moving further, let's see some if they have asked like lot of things, like x to the power x plus y to the power 2. You can say x square plus y square plus 2xy, right? So this is easy. What if they ask x plus y to the power 100? Like, of course you can calculate, but it will be slight harder to calculate. Fine. So but yeah, you can actually calculate to the power 5, but a lot of students don't know, right? So in this case only, we have discovered something called Pascal's triangle. So let's say x plus y to the power 4, we need to calculate it. So how will we calculate? So what does Pascal's triangle say is, like, write 1 1 in each side. Fine. So write 1 1, add this both and write it here. So similarly, write 1 1, add this and fill here. So 1 plus 2 is 3 and 2 plus 1 is 3. Fine. So similarly, add this, add write 1 1. Fine. 4 6 4. So these numbers are nothing but coefficients. Right? This is coefficient of 4 degree equation, 3 degree equation, 2 degree equation and 1 degree equation. In this case, we will take 4 degree equation. So x plus x to the power 4 and reduce this and increase the power of this. Reduce the power of x and increase the power of y. For example, we have 4, right? So in this it will become 3, and in this case y's power is 0. In this case we will take 1. So similarly you will do until y power gets the maximum value. Plus y to the power 4. Fine. So of course it will have some coefficients, right? That's why we use this Pascal's triangle. Just copy it as such: 1, 4, 6, 4, 1, and this will be the expansion of this. I hope you understand this. But if they ask to find the expansion of x plus y to the power 100, it is basically impossible to calculate, right? Of course you can get it by the Pascal's triangle method itself, but it's not practically possible. So that's where we get into new concepts. Okay, now we know that NCR is equal to n factorial by n minus r factorial r factorial. Okay, this is the formula, but won't it be difficult for calculating for each and every single term? So we have some shortcut or the direct methods, direct answers for some values, which is NC0 is nothing but 1, and remember that NC0 will be equal to NCN. This is the first case. Okay, and secondly, NC2 will be equal to NCN minus 1. Okay, and that will be equal to n minus 1 by 2. Fine. And the third, NC1 will be equal to here n minus 2, not n minus 1. Fine. Here NC1 will be equal to NCN minus 1. Fine. That will be simply equal to n. Okay, so remember, what about NC3? So it will come like n minus 1, n minus 2 divided by 3 factorial. Fine. So now you can observe a pattern, right? This is n minus 1 by 2, and this is n, and this is n minus 1, n minus 2 multiplied by n by 3 factorial, right? So that's how this happens. For example, 7, 3, you will simply write 7 multiplied by 6 multiplied by 5, 3 consecutive terms multiplied divided by 3 factorial, which is around 35, right? So similarly, if they asked you to calculate 7C4, what will you do? You will simply write 7 multiplied by 6 multiplied by 5 multiplied by 4 consecutive terms divided by 4 factorial, right? This will be the answer. So remember, NC0 will be 1, NC1 is n, and NC2 is n minus 1 by 2, and so on. The series will be continued. Okay, now we will be seeing statement of BT, binomial theorem. Fine. What is the statement of binomial theorem? For example, if we need to expand this, we use an expansion nc0 xn y to the power 0 plus nc1 x n minus 1 y to the power 0 plus so on, and then final ncn y to the power n. This is the general statement of binomial theorem. Okay, so in this you can clearly see it starts from 0 and goes to n, right? So since it starts from 0, total number of terms is what? N minus 1. Fine. Going further, and two extra things are also important, in which we will take one as 1 and another as x to the power n. How will you expand this? You get nc0 x to the power 0, right, plus nc1 x to the power 1 plus nc2 x to the power 2 plus so on till ncn 1 to the power 0 x to the power n, right? So this is how the expansion will be there. So in generally I can write r starts from 0 to n ncr x to the power r, right? This is the general term or the sigma equation, whatever you call it, right? So what if I substitute x as minus x in the same? Minus x, I'm going to use at 1, okay? 1 minus x, I'll get alternative signs, right? X to the power 0 minus nc1 x to the power 1 dot till ncn minus, so yeah I've taken it, so and x to the power n. So how will this general term will be? It's n c r minus 1, okay, minus 1 r xr, right? So this will be the two important equation which you must understand, right? So let me give an example for this. 20 cr 3 to the power r, we need to find the value of this. So for simply finding this value, I can see from what this expansion have came, right? So I can see another thing is 1, okay, 1 plus 3, and I can see n is equal to 20, which is 20 will be coming under whole power. So 4 to the power 20 will be the answer, fine. So I will give another question. R equal to 0, 35 and 35c r minus 1 by 4r. How will you get the answer? So simply I can tell the first term and the second term is coming under the power r, right? So I can tell it's gonna look like 1 by 4 to the power 35, okay? So I'll get 3 by 4 to the power 35. This will be the answer, fine. So let's solve some questions based on this. Okay, sorry, before that we need to complete something. We need to see 4 important formulas four important formulas. First formula, NCR is equal to NC n minus R. That's what we have discussed this application before. We said that NC0 is equal to NC n, right? So substitute here R is equal to 0, you will get this equation back, right? So this is an application of that. Fine. Okay, let's go for second, which is very important, and you will see a lot of questions. This is called a Pacman's equation. You will get like NCR plus 1, you will get like n minus n plus 1 CR plus 1. Fine. This is very important equation, remember it. Let's go for third equation, which is NC. If it is NCR, you can write it like n by R n minus 1 CR minus 1. Fine. And fourth, you can write it like, if NCR by NCR minus 1 are there in division, you can write it like n minus R plus 1 by R. Okay, and if you convert, so this is an equation, when if you convert R to R plus 1, you will get like NCR plus 1 by NCR, which is equal to R minus n minus R by R plus 1. Fine. These are the four important formulas, and with this we will be solving a lot of questions. Fine. So coming back to the question which we have left to solve. So this is the question. We have 20. I starts from 1. Okay, so it's 20 Ci minus 1 by 20 Ci plus 20 Ci minus 1. Okay, so as you can see, the down part is a two consecutive terms in the I, right? So this I in the sense this thing. So I can use this Pacman's equation, which I said most important, that is the most important, right? So these are also consecutive, right? So, and this also doesn't change, so I can directly use it. So n plus 1, which is 21 C, what is I plus 1, right? So in this case we don't take I plus 1, so this is the minimum term, so we plus 1 with this, so I will get something like I, right? So which is divided by 20 C I minus 1. Fine, whole cube. It's happening under sigma. Fine. So I can also write it as Ci minus 1 divided by 21 by I and 20 Ci minus 1, right? So using this formula, right? Using this formula I can write it like this. So this and this will get cancelled, and I'll get I by 21. So the limits are I is equal to 1 to 20, right? So we have a formula for this. We forgot the whole cube. So we have a formula for this. it's simply 20. So the cube of first n terms is n plus 1 by 2 whole square. I'm going to use this on I. So what will I get? 1 by 21 whole cube multiplied by 20 multiplied by 21 by 2 whole square. When you solve this, you will get the answer. Fine. So let me solve this. What will you get? 100 by 21 is equal to, we need to find k by 21, right? So k will be 100. Fine. Okay, going to the next question. If the coefficient of 3 consecutive terms of an expansion 1 plus x to the power n are in the ratio, then the coefficient of the fourth term is, let's take the 3 consecutive term as NC R plus 1, and let me take 1 before, NCR minus 1. Okay, now we have given this is in a ratio 1:5:20. So if we have given 3 equation, I should take this and this and this and this, which means NCR by NCR minus 1 is equal to 5:1, and NCR plus 1 by NCR is equal to 20 by 5. Okay, so now let us solve this. So simply NCR by, so we should just use that this equation, right? N minus R plus 1 by R. So N minus R plus 1 by R. So what is N here? N is N. What is R? Plus 1 by R is equal to 5. So similarly, what we'll use for this? So we'll use N minus R by, so hope the equation is correct, N minus R by R plus 1, so which is equal to 20 by 5, right? So N minus R plus 1 is equal to 5R. So N plus 1 is equal to 6R. Here 5N minus 5R is equal to 20R plus 20. Fine. Two variables and 2 equations. So you can solve this, right? So let's not waste more time on that. The next question, the coefficient of 3 consecutive terms are in ratio. Okay, coefficient of 3 consecutive terms 1 plus x n plus 5 are in the ratio. So simply I can use the same concept. I can take the 3 variables and take the ratios, but the only thing which I have to change is, in place of n minus R plus 1 by R, right? In this case I will take n plus 5 minus R plus 1 by R. That's it. Put that, solve it, and that will be the answer. Fine. Going to next question. So value of 50 minus R C6. So it comes under sigma 20. Fine. We need to find this value. So let's like expand it. R is equal to, it starts from R equal to 0, right? C6 plus 50, sorry, it's 6. Yeah, it's 6, fine. And put R equal to 1, you will get 49C6 plus 48C6 and so on till R equal to 20, which is 30C6, if I'm not wrong, right? So now let's just reverse this equation and write 30C6 plus 31C6 plus dot 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 till 48C6 plus 49C6 plus 50C6, right? So yeah, so what's the problem with this? No problem. So just add 31C7 and subtract 31C7, fine. So have you seen this, how to add this and write? We have seen it, right? Sorry, 30C7. Okay, 30C7 plus 30C6. Which formula will you apply? So you will apply n plus 1 r plus 1, right? So 31C7, fine. So similarly you will combine this and this and you will write 32C r plus 1, which is 7, right? So this process will be coming till the last term, and I will say a shortcut trick to remember this. If you want to combine these all things, you can see the last term and just add 1 in the n place and add 1 in the r place, which is c plus 1 minus 30C7, right? So you'll get 51C7 minus 30C7, and that will be the answer. 51C7 minus 30C7, option B, fine. Okay, so we have another question, 51 minus K3, and we have sigma also. Okay, so how will you solve this equation? This is equal to, let's try to understand this graph, the expansion. Let's put, we'll get 3, right? 3 plus 50C3 plus dot 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 till 45C3, right? So at the same step, take it backwards, 45C3 plus 46C3 plus dot 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 till 51C3, right? So again do the same step, you will get plus 46C3, so 45C4, right? So just add it, 45C and what I said, just 52C4, right? 4 minus 45C4, fine. So what will be the final answer? Yeah, this is the final answer. What else? So this is option number C, right? Yeah. So yeah, going to next question. N greater than or equal to 2 is a positive integer, then the sum of series. So don't look at this complicatedness and all, just write it so that you will get clear of this. Fine. 2 2. So it's starting from 2C2, right? Okay, so the moment when you see it's not starting from 0. See, whenever this is same, you need to go for one and only condition, which is Pac-Man condition. Fine. So nothing like this is the same condition which we are discussing for this much long time. It's simply like when you solve this, what I said, n plus 1 C3, right? So that's it, we have got the equation. So we need this. So what I will do, let's take the formula to simplify. n plus 1 by 2 plus 2 n plus 1 n plus 2 by 3 factorial, right? So simplify and get the answer. Let's not waste more time. Fine. So yeah, that's easy, right? So yeah, 40C0. The next question is something like they've given this, and where m and n are co-prime, then the value of m plus n is. So simply they have given a series. So 40C0 plus 41C1 plus 42C2 till 60C20. In this equation, see, this is varying and this is also varying. In that case, we can't solve. So there is a trick for this. Not a trick, you need to understand this. So what is 20? So I have told like NCR is NCR is equal to NCN minus R, right? So just apply this here. So I'll get like 40C 40 plus 41C 40 plus dot till 60C40, right? And again the Pac-Man's theory, you will get 61C41, right? So we need in terms of this, so 61 by 41, 60C40, right? So yeah, what else? 60 m by n is equal to 61 by 41. M plus n is equal to 61 plus 41, which is equal to 2102, right? So that will be the answer for this question. Fine. Try this by yourself. Fine. Let's go for the next concept. So before going there, a lot of them can ask like, if I have added this, I should have subtracted also, right? Like the one I've done here, right? So I have added and then subtracted here. So in the same way I should have done there also. So the thing why I didn't do is, we have a term like 40C40, right? So I can just casually convert this into 41C41, right? Because 40C40 is also 0, 41C41 is also 0, and this is how we need the terms so that we can combine, right? So this is not a wrong thing, which is actually correct thing. Both are equal to 1, so I didn't subtract anything, so I got the answer. Okay, don't get confused with that. Fine. Let's go for next concept, important terms. So we see something called general terms. Okay, so general term is nothing but x plus y to the power n is equal to nc0 x to the power n. We know this equation, right? Ncn is equal to y to the power n. We know this equation. We consider this entire term as term 1, and this will be Tn, right? So the general term can be written as NCR x n minus r y r. This is the general term, and remember r is taken n minus 1. For example, t, we need to find t6, then we should write it like this, and this is r, right? 6, let's say in expansion something like 5, I'll write 5 c 5, right, which is 1, and we will get some value here. So don't confuse. The thing is, we need to take r plus 1, okay? In that only r should come, fine? Okay, let's solve some question based on this, fine? So coefficient of x to the power 5 in the expansion, this, okay, minus 1 by 3x square all to the power 5. Fine, we need to find the coefficient of x to the power 5 in this. So simply write its expansion, which is like a general term, fine? So 5 cr 2x to the power 3, 5 minus r, and minus 1 by 3x square to the power r, fine? So take x terms, and I wanted to tell that the difference between coefficient is entire terms that comes in front of a variable, fine? So whereas a binomial coefficient is that NCR, these terms are called binomial coefficient. You must understand that difference, okay? Coming back here, write 2 5 minus r and x to the power 3 5 minus r. Just multiply it, you will get 15 minus 3r, and you will get minus 1, and again 1 by 3, let's say, let's include it with that, okay, and that will hold a power r. And I can also write x 1 by x square as x to the power minus 2 to r, right? So I can write 2r. So I can combine this and this, I'll get something like x to the power 15 minus 3r minus 2r, which is 5r. Okay, this will be the variable part. The coefficient part is cr 2 5 minus r minus 1 by 3 r, fine? This is the power of this, and we have given the power of that should be 5, is equal to 5. So I'll get minus 10 by minus 5, which is 2. So we have got r equal to 2, and substitute r equal to 2 in this coefficient part, we'll get something like 3 minus 1 by 3 2. Yeah, solve this and get the answer, fine? I hope you can do this. right? 5 multiplied by 4 divided by 2, 2 to the power 3 minus 1 by 3 whole square. Yeah, I think this is not a complicated thing. You can do this by your own, right? Okay, let's solve another question. So this is similar type of question. Let a and b be two non-zero real numbers. If the coefficient of x to the power 5 in the expansion ax square plus 27bx to the power 4 is equal to the coefficient of x to the power minus 5, okay, in the expansion. Okay, the value of 2b, fine, it's a easy one. So just separate it, expand it, we'll get 4cr a to the power 4 minus r x to the power, which is 8 minus 2r. Am I right? Yeah. And 70 by 27bx. So I can take it r, let's put it here, and x to the power minus 1, which is minus r, right? So 8 minus 3r is equal to what? 5, right? 5. So I'll get minus there, get minus 3 by minus 3, which is r equal to 1. So similarly do it here. Ax, expand it, 7cr a to the power 7 minus r x to the power 7 minus r minus 1 by b to the power r and x to the power minus 2r, right? So minus 2r will combine with here and it will get minus 3r. 7 minus 3r is equal to minus 5. Am I right? Yeah. So minus 12 by minus 3, you will get 4. R is equal to 4. Okay, apply the R value here, and they have given that both the coefficients are equal, and then equate it. So 4c 1 a 4, which is 3, 70 27 b to the power 1, which is nothing, okay, is equal to a, and we get 3 minus 1 by b 4. Yeah, solve this equation and you will get the answer. Don't worry, there are two equations because a cube will get cancelled. Okay, after getting the b value, just substitute in the equation again, you will get the a value. Fine, this is not so complicated, right? So, and yeah, in question also they are asking 2b value only, no, so we need not to calculate a value also. Fine. Okay, the next thing, term from the end. So we need to learn this concept for a lot of question applications. So we will also face some direct questions also. We have two methods for this. Let's say method 1, a complicated method, x plus y to the power 5, let's say. Let me give the theory first. Fine. The theory is kth term from the end, x plus y to the power n is equal to kth term from start of x plus y plus x to the power n. I hope you understand this, right? Okay, like x plus y to the power 5, you need some third term. Let's say you should write y plus x to the power 5's expansion and calculate the third term for that, but it is not easy in lot of cases, right? So this is a bit of difficulty. It is increasing the difficulty of the problem. The problem itself is a huge difficulty for a lot of students, but this will actually add some difficulty, so we need not to go by this method. There is a lot easier method for this. That is nothing but formula method. So what is the formula method? Kth term from end is equal to n minus k plus 2, the term from start. Direct formula, remember it. For example, we have given something like this, and we know there will be some 7 terms, right? So 7 terms. So we need to find the third term from start, so from end. What will be the term from start? Simply 7 minus k, which is 3 plus 2. Okay, 7 minus 3, 4, 4 plus 2, 6. Sixth term from the start. Fine. So yeah, let's solve some questions based on this. Fine. Let's say if this term from the end in the binomial expansion is expansion this thing and is 1024 times 1011 the term from the beginning, then mod x is equal to. Fine. So for this question, how we need to approach is the same way. Find the term from the start. So simply apply in that formula, which is n minus k plus 2, right? This is from the end. So from the end is also given minus 1011 plus 2, which is 1011 1013, right? From start. So simply I can write 1013 is equal to 1 T1013 is equal to T1011 multiplied by 1024, right? So let me write it in NCR terms. NCR, what? N is 2022, CR, which is 1012, right? We need to take 1 minus for R, and 4x by 5 to the power this minus this 1010 and minus 5 by 2x to the power 1012, which will be equal to 1024 multiplied by 2022 C 1011 4x by 5. So this minus this 1011 multiplied by minus 5 by 2x. So 1 0 1 1, right? So if you say correct, it is absolutely wrong. So we need to take r minus 1, right? R as n minus 1, right? So I should write 1 0 1 0. Okay, so you guys are wrong here. Okay, Navya. So we have got these this one equation, fine. From this, can I say if you observe a relation, fine. So what is, let's take this is NCR, and what will be n minus r? This will be this, right? So these both are equal as per this formula, so I can cancel this. Okay, I can also cancel this and this power, and I can write it as whole to the power 2, right? So I'll end up something like, and this also I can cancel, sorry, can cancel, and this entire term also I can cancel, which I'll end up like 2 is equal to 1024 4x by 5 ka whole square multiplied by what? 2 to the power 10. So I can write this as 2 to the power 10, fine. So from this, just the calculation part you can do. Okay, I think you will get confused in this mod thing, I think. So let me do it for you guys. So I'll get 25 4x square, right, is equal to I'll get 4 to the power 2 x by 5 square multiplied by 2 to the power 10, right? So yeah, take x on one side and others on other side, get 5 to the power 4 divided by 2 to the power 16, put 1 by 4 1 by 4 so that x will become an independent number, variable. So you get something like this, sorry, will be converted and you get something like this, which is 16, fine. So as you see, this is x to the power 4, right? So I can put a mod, because when you take the value of this, it can be plus or minus, so I can put mod, and this will be equal to this, so there will be no changes. So yeah, next we will be seeing some concepts again. So middle term, fine. So middle term is divided into two types of situations where n is equal to odd. When n is odd, the middle term will be term n plus 1 by 2 and next term. Okay, so when n is even, the middle term will be t is equal to n by 2 plus 1, fine. This will be the middle term. Yeah, this is a condition, and let's see one question based on this. Okay, let's solve a question. The ratio of the coefficient of middle term in an expansion of 1 plus x to the power 20. So what is the middle term in this expansion? So n is even, right? So t 20 by 2 plus 1, which is t11. So middle term of this expansion is t11, and the sum of the coefficient of two middle term in the expansion of is, so two middle term will come for sure, and it will be t n plus 1 by 2, right? So n is here 19, which is t10 and t11. Okay, now what is t11, which is 20c 10 x to the power 10, right? X to the power 10, right? So fine, this is the middle term of this. And what will be the middle term of this? What will be the term of this? So 19c9 x to the power 10 y to the power 9. So similarly here 19c 10 x to the power 9 y to the power 10. These will be the middle terms. In this case y is 1, so I can cancel these both, right? Sorry. In this case x is 1 and y is x, so I can convert it like this. Fine, yeah, now it's correct. So what they have asked, the ratio of the coefficient of middle term in an expansion. So this x to the power 10 divided by the sum of coefficients of the middle term. So sum c9 x to the power 9 plus 19c10 x to the power 10. They are asking this. So since they are asking coefficients, we can cancel these variables. We don't need these variables. The sum of coefficients. Fine. I didn't see it. Okay. 20c10 divided by. So this is Pacman's theory, right? 20c10. So this and this will get cancelled and you will get 1 as the answer. Fine. Okay. Fine. So now we should see something called term independent of x. Okay. So what is term independent of x? Simply this is a very easy thing. You need not to complicate. The thing which we have learned already, like we need to find we have seen a question like we need to find the coefficient of x to the power 5. We have seen, right? We have equated to something. So simply x to the power 0 is equal to 1. In this case the equation will be independent of x. So simply we need to equate the power is equal to 0. For example, in the last case, if you remember, you will get something like 10 minus 2r minus 3r, right? So you will equate it to 0. That's the only thing which you have to do. Fine. So let me give an example for that. The term independent of x in expansion of root ax square plus 1 by 2x cube to the power whole to the power 10. Is 105. Fine. A square is equal to fine. The term independent of x in the expansion root a x square plus 1. So let's directly write the expansion of it. 10c r root a to the power 10 minus r x 20 minus 2r plus 1 by 2 r. Okay, so x to the power minus 3 r. Fine. this will get 5r and this will get multiplication, sorry. Okay, so in this case I can write minus 5r equal to 0. Fine. Minus 20 by minus 5 will be equal to r, which is 4. R equal to 4 in this case. Fine. And we have given that term is equal to 105, which means 10c 4 root a 10 minus 4 6 and probably that term will involve x, so that probably they should have given that the coefficient is equal to 105. Fine. So I can equate it to 105 and you can get the value of a linear equation in one variable. I think it's not too tough to solve. Okay, the next thing we'll be seeing is rational and irrational terms. Okay, rational and irrational terms. So this is a methodological based questions will come in this. So you just follow this method and get the answer. It's like that type of questions. So like as I said, so I will explain this with an example itself so that you can understand it better. Okay, the number of irrational terms in the expansion 4 to the power 1 by 5 plus 7 to the power 1 by 10 whole to the power 45 is. Okay, so as you all know that this is equal to n is equal to 45. So total number of terms will be equal to n plus 1, which is 46, right? So we need to find how many rational, how many irrational. So step 1 is you need to make this base at subprime factor. So you should write like something like this. So 7 is already prime number, so we need not to take care of it. So 1 by 10 to the power 45. Fine, this is the step 1. And what is the step 2? Write the general term of this. Fine. So expansion of this. Fine. 45c r 2 5 45 minus r. Okay, 7 to the power 1 by 10 multiplied by r. Fine. Yeah, now 45, we have got 45 cr. So we have got 45 cr 2 to the power 5, right? Hope you agree with this. Fine, now this is the important process. Use hit and trail method. Fine. Use hit and trail method such that these two powers should be an proper integer. Okay, let's try by putting it 0, and you should also note that r should be greater than or equal to 0 and r should be lesser than or equal to 45. Fine. Okay, now put r equal to 0. Of course this is an integer and you will also get 0 here. This is also an integer. Fine then. So the first integer will be r equal to 0, and after doing a lot of problems they have observed that this is gonna give us an AP, which is arithmetic progression. You will learn in sequence and series. That will be my next video. Arithmetic is nothing but arithmetic progression is nothing but with the common difference. Let's say if there is 0, 10, 20, it will have common difference in their series. That will be an arithmetic equation. So in this case it is an arithmetic equation. And what is the common difference of this? It is just the LCM of this and this, the denominator of this and denominator of this, which is 5 and 10. Okay, what is the LCM? It's 10, right? So the common difference D will be 10. So 10, 30, 40, right? 50 won't come just because of this condition. Fine. So R belongs to these all values. Fine. So what are they asking the question? The number of irrational terms, right? So the rational terms are 4. These are rational terms, 4 rational terms, and we have got total number of terms is 46, and if we subtract the rational terms we will get irrational terms, which is 42, right? I hope this is clear. Okay, next concept we will be seeing on greatest binomial coefficient. Greatest binomial coefficient. So for this we need to take an observation. Fine, let's take a random variable. Let's say 5c0, 5c1, 5c2, 5c3. This is binomial coefficient. Don't get confused with coefficient. This thing is binomial coefficient. So it will go until 5c4 and 5c5, and we can observe that this value is 1 and this value also will be 1. So similarly, what will be this value? Which will be 5, which will be 5. This is n, right? So n is 5 here. Okay, so what is this value and this value? We know that this and this value will be equal because 5c2 is equal to 5c5 minus 2, right? So which is 3. These two will be equal. And what will be this value? We will get something like 5 multiplied by 4, 2 factorial, right? So this will be 5 multiplied by 4 multiplied by 3, 3 factorial. So this will be 6. So this and this will be 2. Here it will be cancelled 2, which is 10, 10. Fine. So as you can see, when there are odd, n is odd, we see this middle term's coefficient is the greatest, right? So I can generalize it as when n equal to odd, the greatest coefficient will be ncn minus 1 by 2 and ncn plus 1 by 2. Okay, and if n is even, it will be nc n by 2. Okay, let's go for the further, which is numerically greatest term. Okay, numerically greatest term, we will say NGI. Okay, these are the first letters, it doesn't matter. So simply numerically greatest term we can complete it in 2 steps. Okay, step 1, step 2. Fine. So just applying this formula, n plus 1 by 1 plus first term divided by second term. Fine. What are this m, what are this n? M and n are nothing but m is the value of this. Fine. And n is nothing but, if there is something like this equation, this is n, this is the n which we are seeing from this much time. Okay, and we should, second step, we should apply in this condition r and lesser than m. Fine. So let me explain this. A lot of them may not understand this, so with an question you will be understanding it crystal clear. Okay, find the numerically greatest term. I hope you should understand the reason why I take photos of the questions. My handwriting sucks, right? Expansion of 7 minus 5x to the power 11, where x equal to 2. Fine. Okay, we need to find this. So as the first step we need to find m. Okay, m is nothing but n plus 1 by, so 11 plus 1 by 1 plus mod of first term, which is 7. What is second term? 5x. Okay, mod, we have given x is equal to 2. Let's substitute x is equal to 2. So what will you get? 12 by 1 plus 7 by, okay, yeah, 7 by 5, sorry, 10. Fine. So what is 7 by 10? We get 0.7, 1.7, right? 1.7. So if you divide this, what will you get? So it will come like 7.1 something. Okay, so now we will be going for the second step. We are applying that range. Fine. So this is the value of m, right? So what is m minus 1, which is 6.1, greater than or equal to r, which is lesser than or equal to 7.1 itself. So the only integer which will be in between is what? 7, right? Okay, I hope you got it. R will be equal to 7 and t term, 8th term, will be the numerically greatest term. Fine. Okay, now are you comfortable, or yeah, let me go for another question. Okay, we need to find the numerically greatest term in this expansion when x is equal to 1 by 5. Okay, so method 15 plus 1 by 1 plus 3 by minus 5x, right? So x here is 1 by 5, 1 by 5, 5 will get cancelled, and I'll get like 16 plus 1 by 3, which is equal to 4. Fine. So this is step 1. What is step 2? Apply in that range. So 4, right? m minus 1, m. So in this range there will be existing two two numbers, r is equal to 3 and r is equal to 4, which means t4 and t5 will be numerically greatest, and another relation is t4 will be equal to t5. Fine. Okay, let's go further of finding remainder. Fine. So finding remainder, let's go for a question. Let's say we need to find the remainder when 248 to the power 2024 is divided by 21. What will be the value? So simply I can write, so just see the nearest term which is divisible by 21. So I'll go for this, right, multiplied by 20, right? So I can go for this, plus 8 to the power 2024 divided by 21. In this case you can cancel it like this, and what you will remain is 8 to the power 2024 divided by 21, right? Right? So yeah, you can write this as 2 to the power 3 2024 by 21. Okay, and I can write 2 to the power 6 and 1010 by 21, just because I can separate this 2 to the power 6, which is 63 plus 1 by 21, 1012, right? And the remainder will be 1. So basically easy method is just separate this so that this divides this number, okay, in such a way that 21 divides the number, and then you will get this part. And now you need to find, to make this an prime factor and see whether this 21 can divide something near to that. Fine. So when you divide and divide, finally you will end up in the remainder. In this case it is 1. Fine. So moving further, we will see sum of binomial coefficient. Okay, just understand these three things, that is more than enough. nc0 plus nc1 dot 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 till ncn is nothing but 2 to the power n. Fine. And the number of odd terms, number of even terms, nc2 plus dot 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 till nc2n. Sorry. So it depends on n. Okay, so it will come like 2 to the power n minus 1. Fine. nc1 plus nc3 plus dot dot dot, you will also get it n minus 1. If you want the derivation, it's so simple. Let's say for first one, how will you derive it? So let's take 1 plus x to the power n. In this case, you'll see an expansion for this. You'll get like nc0 plus nc1x plus nc2x square dot dot dot, right? In this case, put x is equal to 1. Fine. So what will you get? nc0 plus nc1 plus nc2, you'll till ncn, you will get the value. If you substitute this and this, will be 2 to the power n. This will be the value, right? So hence proved, right? So what about this? So let's say let's substitute in this formula nc0, we'll get like something like this, right? 1x, sorry, yeah, correct, plus nc2 x square minus something, right? So in this case, let me just take these odd terms on other side. I'll get nc1x plus nc3x nc0 plus x cube, right? X cube, yeah. nc2 x square, I can say like this, right? So in this case, what I'm going to do is I'll put x is equal to 1. So I'll remove all the x part. Fine. So let's take this, and this is y, because they both are equal. So if you take x is equal to y, I can take both are y. That doesn't change. So I can write 2 to the power n from this. Again, is equal to y plus x plus y, right? How many of you agree this, right? So 2 to the power, sorry, 2y is equal to 2 to the power n. Okay, if I take 2 on the other side, I'll get 2 to the power n by 2, which is equal to y, and I can write this as minus 1. This is how you will be proving this equation. Fine. Okay, moving further, sum of coefficient. So sum of coefficient, so what we have seen before is sum of binomial coefficient. In this, if there is xy term like this, the entire term that comes before this variable is called coefficient. And how will you find the sum? Let's take an equation, and you will get something like this, right? Okay, just it is a simple method. Put x is equal to 1. Okay, and what will you get? 3 to the power 20 will be the answer, will be the sum of all the coefficient. Fine, that's it. For example, 3x square minus 5 by y plus 7z to the power 100. We need to find the sum of the coefficient. Put all the variables is equal to 1, all the variables x, y, z, all the variables. I'll get 3 minus 5 minus 7, which is what? 3 minus 5 plus 7, which is 5 to the power 100. Fine, this is easy, right? So let me solve some questions based on this. So here is the question for us. A denotes the sum of the coefficient, not binomial coefficient, it is coefficient. N the expansion of, let's take this, fine. And B denotes the sum of all the coefficient in the expansion of x square to the power n. Fine, put x is equal to 1 here. So what will you get? Minus 3 plus 10 to the power n, and here 1 plus 1 to the power n, which is 2 to the power n. And what will you get from here? Which is 7 plus 8 to the power n, right? So what they are saying, and this is A, this is B. If A denotes the sum of all the coefficient of the expansion, and B denotes the sum of all the coefficient of the expansion in, then okay, what is the question? Okay, we need to find the relation between A and B, let's say. Okay, so to find the relation between, yeah, it's simple. It's to the power 3 to the power n is equal to A. b is equal to 2 to the power n, right? So just shift it, you will get n to the power 3 and b is equal to 2 to the power n. So a is equal to b to the power 3. That's it. This will be the answer. Fine. Let's go for another question. So this is a good type of question which makes us to think whether this is this chapter or not. But yeah, in reality it is this chapter. Fine. So can I write this thing as n factorial by n minus r factorials, right? So yeah, you can see like r is 1. So how did I come to this? Because all the sum, if you see 5 plus 46 you will get 51, and all the sum is constant, so I can tell this is in this form. Fine. In this case r is 1, c is 51 minus 1, so n is equal to 51, r is equal to 1. Okay, but there is a missing term which is n factorial. Okay, so I can take n factorial as common outside 51 factorial, and I can write in this term, right, NCR term. So how will I write? NC1, here n is 51 for the first term, so similarly I can write 51C3 plus 51C4 till 51C0, right? Wait, is it 0? Sorry, 51C51. Okay, yeah. Now what we should do, observe this. This is an sum of odd terms, right? 2n minus 1 will be the answer straight away. 2 to the power 50 multiplied by 1 by 51 factorial. This will be the answer. Yes, right? So easy answer. Fine. Let's go for another simple question. So this is an equation already given, 1 plus, so this isn't, as you can see, this is NC1, NC2, this is still 49. This is easy to calculate. In that case you can write it like this, because it should start from 0, then only you can apply the binomial coefficient is equal to 2 to the power n. So I can write 49C0, this is of course equal to 1, right? Plus I've divided this into two types. Okay, that's 1 and 49C0. Hope you understand. 49C1 plus 49C2 till 49C49. Fine. This we know, that is 2 to the power n. 2 to the power n. Fine. And what about this? 50C2, 50C4 till 50C50, right? So 50C0 is missing, 50C0 is missing. So what is 50C0? Which is simply 50C50, right? So I can just add and subtract this 50C0. So this 50C50 will be cancelled and it will be running till 50C49. That's it. So 48 in this case. Or I can also write it like 50 minus 1, right? Because 50C0 is 1. So I can also write it like this. Because for the simplification, I'm gonna write it like this. So I'll get 49 minus 1 as one bracket, and I'll write What about this? 49. Yeah, and this will be this. I wrote it like that for this simplification. Okay, which is 1 plus 2 to the power 98 minus 1. Okay, so what are they telling? It is equal to this, right? And dot m. Fine. So this and this will get cancelled, and 2 to the power 98 multiplied by 1. So 98 plus 1 is 99. Fine, that will be the answer. Okay, so the next thing is multiplying binomial coefficient. So simply, if it is something like this, multiplying this will be the answer. Okay, this is a shortcut. NC0 plus MCK minus 1 NC1 plus dot 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 till NC0 NCK. Fine. So this is a condition only when you should use it only when it is in multiplication, and then the sum of this is constant. Fine, sum of this is k, sum of this down terms is k. Fine, this is also k. Sorry. Okay, so if these are same and if it is a constant, I can write it this entire summation as m plus n by m plus n ck. Fine. Okay, let me have a question. We need to find 22 r equal to 0, 22 cr, 23 cr. We need to find this value. Fine. So simply I can 22 cr equal to 0, right? So as I said here, m plus n ck, which is 22 plus 23, which is 45 ck. So in order to find the constant, we should write one or two terms so that we will get a clear idea of constant. 0, 20, 23 c. Okay, this is not the question. Okay, let us put the question like 23 minus r. Fine, I think now it comes correct. 23 minus r is 23. Fine. Okay, so I can write, so this is clearly in this form. I can write it as 23 because this and this summation is 23, right? So I can write it as 23, and for this summation is not required because after summation only this value is coming, right? So yeah, and if you observe closely, this will be equal to 22 because NCN R is equal to NC n minus R. Due to that, that will be equal. Fine. Going further, let us learn multinomial. Okay, so multinomial is a very small concept which we can learn in seconds. Okay, x1 plus x2 plus x3, these three terms will come. That's the whole definition of multinomial, whole to the power n. Fine. So how will this general term look? It will be simply like that, right? R1, so 3r will be there, R2 and R3 factorial. Fine. And the term will be x1, R1, x2, R2, x3, R3. and r1 plus r2 plus r3 will be equal to n. Fine. For example, if 3x square minus 1 by x plus 7 to the power 20 is there, what will be its general term? So 20 by r1 factorial, r2 factorial, r3 factorial. Okay, and x1 is 3x square r1 minus 1 by x r2 7 r3, right? So this will be the general term. So let us see a question to understand it very clearly. The coefficient of x to the power 7 in 1 minus x plus 2x cube 10 to the power 10 is. So write the general term for this. What is the general term? So 10 factorial, which is n factorial, divided by r1 factorial, r2 factorial, r3 factorial, and 1 to the power r1 minus x to the power r2, 2x cube to the power r3. Fine. So we know that r1 plus r2 plus r3 is equal to 10. Okay, and we have given an equation like coefficient of x to the power 7, right? So which means this and this and this will be multiplied with this, and you will get something like 3r3 will be equal to 7. Fine. Now we know that r, all these 3r will go till n and will start from 0, right? So in that case I can take any values 1 2 3 till 10. Okay, till n. In this case n is 10. Okay, and see the maximum power coefficient, maximum r's coefficient. In this entire equation, 3 is the maximum coefficient, and it is the coefficient of r to r3, right? So let me substitute r3, r2, r1. r3 is equal to 0. So if I substitute r3 is equal to 0, then r1 will be 7. Since the entire sum should be 10, I can write this as 3, right? So similarly I can write 1. So we'll get 3, which is 4 and 5, right? Okay, similarly 2, 1 and 1, right? So similarly 3, what will come here? 3 negative, here negative, so we will terminate before this itself. Fine. So how will this term will come? It will come 10 factorial by 3 factorial, 7 factorial, 0 factorial, 1 to the power 3 minus x to the power r2, which is 7, and 2x cube to the power r3, which is 3. Here similarly an equation will come. Let's say this is x and this is y. Okay, let's take a and b. Fine. So finally what we should do is add these 3. Okay, adding, let's say this is c. A plus b plus c will give us the coefficient of x to the power 7. Fine. This is all about multinomial, and a lot of questions you will see in not JEE means, but you will see in exams like BitSat, fine, which will test your speed. You need to do as fast as possible. So I think this video has become a big video, a long stretched video. So let's see the remaining things. That's based on question, like all the concepts has been covered till now. The only concept left is sigma concept, so that we will see in next video with some questions. Fine. So that's it for today. See you in the sequence and series, I think. So until then, bye bye.